have no idea what happened.
Now just don't touch it.
Of course, and now I'm not even sure I logged into the right thing.
People are there.
Yeah, okay.
Just do the thing to let people in.
So I think I got it restarted correctly. Yeah, I don't know. Blame the hotel. Because it like died out and I couldn't get the camera to work.
So is everybody back, you think?
No, not everybody logged back in. I think yeah, okay, there's some of my other people. Yeah, frustration. All right. Everybody have actually see me and hear me now? Hopefully. Okay. So any last questions then about homework stuff? Otherwise, I want to talk about one of the lab calculations a little bit, something that we didn't have a whole lot of time to do for the previous lab cycle. I wanted to talk a little bit about the calculations for doing the vinegar analysis, because that's one that hopefully some of my people will be turning in tomorrow, or at least turning it in soon if you need to scan it and turn it in. So let me see if I can use the whiteboard thing on this. All right. So one of the things it asks you about when you are doing the vinegar analysis is you start with the mass of your vinegar. Okay. And for most people, this is somewhere in the neighborhood of between 4 and 5 grams. So I'm going to pick kind of a random number here, and we will say that the mass of vinegar is 4.806. 3 decimal places, because that's typical of our balances. As you are progressing down the page, it will ask you about your initial burette reading, which may or may not be 0, depending upon exactly how you filled it. Let's shoot for one that's like not quite 0. We'll say we started at 1.5 mils. Keeping in mind that burette readings, remember, are supposed to have 2 decimal places. If you think you were right on the line, it might be 1.50. If you were in between 2 lines, your second decimal place might be a 5. So let's say I had a final burette reading of 26.75. All right. It then asks you a number of other things past that. It will ask you for volume of sodium hydroxide used. Now remember, sodium hydroxide is actually what we had in the burette. So I would subtract, and I'm actually going to use my calculator to make sure I don't make any horrific math goofs on this. So if I do 26.75 minus 1.5, that means 25.25 milliliters were actually my used volume. Now your molar concentration is the average of the standardization, part A, from the other lab that we did during the same lab period. So it's probably somewhere in the neighborhood of 0.11, 0.12, something along that line. I'm going to say 0.12 0.22 molar as my supposed concentration from the previous lab. Because since we did all of them during the same class period, we're using the same concentration all the way through. It will then ask you how many moles of sodium hydroxide. So one of the things we need to do for this is we need to change our volume over into liters. So I'm going to move my decimal place. I'm going to do 0.02525 liters. And then I will multiply that by my 0.122. Let me stretch out my box here so that I can go across moles per liter. And if you multiply the two of those together, you should get would help if I actually moved my own decimal place. And this should give me 0.00, we'll say 308. And that is my moles. One of the things you are using as part of your assumption for this particular lab is that you have an equivalent amount of sodium hydroxide and acetic acid. It is a 1-to-1 ratio. So your moles of acetic acid, actually that should be a C, not a B, should then be the same, 0.00308, 1-to-1 ratio. It asks you what the mass of your acetic acid is in your vinegar. So I'm going to take my number of moles, my 0.00308, and if you look back through the pages that are previous in your lab report, that are in the lab book, you will see that 60.05 grams per mole is your molar mass. So if I multiply these two together, that means I had 0.18, oops, I put my decimal in the wrong point, 0.185 grams. Now, look back up here at the top line. We have mass of vinegar. So the mass of vinegar is 4.806. So in order to do my percentage, I'm going to do, so percent by mass of acetic acid in the vinegar. I'm going to do 0.185 because that's how much the vinegar's acetic acid was. But my original sample weighed 4.806. And then I'm going to put the kind of times 100 over here on the end so I can convert it over from a decimal into percentage. So 0.185, and I want to divide by 4.806, and then multiply by 100, and that gave me 3.85%. So because we didn't have a whole lot of time to talk about this, by trying to make sure we got everything done, in lab, I kind of wanted to go back through this a little bit. One of the things to keep in mind, since everybody only did they did 2 trials of one particular type of vinegar, if you come up with a percentage that is under 1%, be suspicious because that is unlikely. We were using kind of normal average types of vinegar. I think the choices that we had out were a white vinegar, an apple cider vinegar, and a white wine vinegar. None of those is particularly unusual. So less than 1% would be very, very weak vinegar. But also more than 10% would be unlikely. So keep that in mind when you are finishing the number crunching for this particular lab. Questions about lab calculations for this one or for the other labs that we've already done? I know that my A group and B group aren't quite in sync right at the moment. That B group is destined to see me on Monday for the last physical lab of the semester, which is the calorimetry lab. We are doing most of it. The carbonate analysis lab became a dry lab that has a video attached to it. Actually, I'm not the one who created that particular video. Mr. Wheaton did. I liked his presentation of the way he took pictures of the balance so that you could then insert data into the blanks on your page, and you'll only have one out of the 2 trials filled in. Even though there are 2 trial columns for that lab, you should only end up having 1 column filled in when you are finished. Questions about lab stuff? All right, let me go back to the thing I was starting to talk about briefly about the 4th test, not the final exam, the 4th test. We are about to start the chapter that includes Lewis structures. And Lewis structures stereotypically involve drawing of the molecules, placing of electrons and lines for bonds and that sort of thing. And Canvas in and of itself, from a quiz/test point of view, doesn't seem to offer me that option. So here is my current thought, and I will talk more about this as we get closer to that 4th test, because we got a whole chapter and a half you have to go. I am thinking about the final 6 questions of the test of instructing people to take a photo and attach, and then convert it over to a PDF and attach the photo of their actual drawings to the test submission. I know that I had a couple of people in the past who, as opposed to typing their work in the box that's provided for problems as opposed to multiple choice and that kind of thing, that some people did something like that. They took a photo and they attached it to the Canvas test submission. And I'm hoping that that will work, because the other alternate would be take a picture and send it to me via email. We could do it that way also. Either way is kind of where I am leaning, because I've been scratching my head for like 2 or 3 days now going, I want to be able to test this particular type of knowledge, but Canvas doesn't really lend itself that way. So I was trying to figure out an alternate way to do so. So I will kind of keep you in the loop, but that's what I am thinking in terms of the final few questions that go on that test.
My thing is the lockdown browser. Like it wouldn't even let me change my internet settings in the lockdown browser. So I don't know how you can't even look at your answers from the test without going back into the lockdown browser. So I don't see how we can upload a file with it. Well, you can't access anything
Because
else.
there should be, okay, at the end of the test, there should be the paperclip symbol.
I don't know. I don't remember. I just remember like one time I lost internet service and it was like freaking me out because it was saying that some of my answers hadn't been recorded. And then when I went in there, like I was trying to go into my computer settings to, disconnect and reconnect, it wouldn't even let me do that. I literally just had to sit there and hope and pray that my internet, rebooted or, caught back onto the computer. It won't let you do anything.
So
So
maybe we should stick with the submission by email
yeah.
as a more reliable way to do it then.
Yeah, because I tried to go back into the test through regular Canvas just to see if my answers had been recorded. And it was like, even just to view what I had submitted, it was making me go back into the lockdown browser just to view what I already
Okay.
had submitted. So I
Okay,
don't,
so that's good. That's a good piece of information to know then. That makes me think that maybe we are safer just having everybody do that last question set on paper and then just send it to my TCC Edu email. And that way I can then just open email documents to grade the final half dozen questions, which are all, like I said, are all kind of like pictures. So yeah, maybe, okay, it's good. It's definitely good to know that. So I will keep that in mind as I finish up typing the test. I'm trying to finish typing test 4 because it takes me an enormous amount of time to do these because I need to get going on the final exam typing here fairly soon. Because yeah, that's going to take a really excruciating amount of time too. But I think as I turn around and stare at my kids, like that was what your calc teacher did, right? She had you email
Sorry, what?
the pictures.
Yeah. Okay. So what I had done is because that thing does not let, or she wanted you to actually show the work for it. What I did is I took all the pictures on my phone, then opened a Google document, just because I prefer Google documents. You could do this on Microsoft Word as well. Open the Google document
and post and paste them.
Load each picture in order, in number order.
Okay.
You're only doing like one or two pictures.
Yeah,
so
one or
that's
two
not
pictures.
super relevant. Just make sure all your pictures are numbered, and then save it as a PDF or a docx. Either one works.
Yeah.
And then upload that as the file rather than trying to load each picture individually as separate attachments.
Okay, so a thought then is if you take photos and you tell it to like load your photos to a document, the documents can be doc or docx or PDF. And then that way you can like paste them into the document. Google Docs apparently allows you to do this, but also probably Microsoft Word does also.
Yeah, it will.
And either way, you can attach it then to an email and then I can open them to view them. And then just that way I can write on them and put like a number value and then look at your number value. Cause like when I'm grading them, each question has a box that for everything that's not auto graded, I can put a number in the box. But if it has like no submission answers or whatever, I can go back and manually put numbers in. So I think maybe that's going to be the best way to do it, the safest way to do it. If it's really being sort of problematic about allowing people to attach files to the test, then it definitely sounds like the email is a better option. All right, and I will keep you guys in the loop about that. I just figured I'd bring it up since it is something that is sort of pending to happen. Final exam is probably going to get loaded on, I actually have to pop my phone open here to look at the dates. Because the final exam week is from the 14th through the 18th of December, so right about a month from now. And there's only going to be just kind of a question and answer review day on Tuesday, the 15th. There's no new there but you'll have taken the fourth test by then. And I'm just going to answer questions on that day. And then you'll probably have from the 15th all the way through until the 17th. I know that's a shorter time period. I'm going to give you shorter number of days, but longer number of hours for the final exam. So my suggestion is you need to plan on taking the final exam on the 16th or the 17th, because Thursday night at midnight, the 17th, is probably when the system to accept the final exam will shut down. So kind of pencil that in as, yeah, I need to block off 4 to 6 hours. Not that I think it will take you that long, but if you want it to take you that long, I'm probably going to give you 6 hours for the final exam. So more information. I'm trying to get people to kind of comprehend, and also to ask me questions though about if there's timing issues, because I don't know exactly how some of the other classes are doing their final exams. I don't know if they're doing them where they started them like that weekend and then they give everybody the whole week to work on them. I'm really not entirely sure how some of the other professors are doing it for other classes, especially. So if you have a conflict, email me. All right, let me talk just a little bit about the beginning of the next chapter. And somebody asked me a question about, okay, if you look at about dropping the lowest score on the tests, I will do that after the 4th test is taken, because I have to go in and tinker with the grading setting for Canvas, because right now it's only set by weight and I don't have it dropping any of the tests. But once we have gotten the 4th test taken, then I will set it to drop the lowest test grade. And it should appear that way, the lowest test grade not being the final exam, because the final exam cannot be dropped. It will happen. It hasn't happened yet. All right. What did I do with my... All right. This should be the beginning of the last set of notes. This particular chapter and a half that we're doing, I didn't do it particularly in the same order in which your textbook does it. It's all the same information. I have a preference for how I present it. So if you're thumbing through the textbook looking for, correlations to go with the notes, you will notice that the order in which we're doing this is somewhat different. So if we go all the way back to the beginning of the semester and we start thinking about how one of the things we commented on was you don't often get, with the exception of noble gases, we don't get a lot of random single atoms, okay? If you think about your coffee, okay, your soda, the chair you're sitting on, all of those things are basically comprised of molecules. Molecules being multiple atoms. So the idea that because those molecules have to be held together with atoms, we need to, or have to be held together with bonds, the atoms have to be held together with bonds. We need to think a little deeper about the bonds themselves. So we can approach this from a couple of different ideas. One of them is the, I'll call it a little bit more middle school point of view of a bond is the force for, can't speak tonight, a force that holds two atoms together. True, not super detailed. If we dig a little deeper, we can say that the link between the atoms results from the mutual attraction of their nuclei for electrons. Now digest that for a second. Okay, nucleus, protons and neutrons. Therefore, we know the nucleus has a positive charge on it. Electrons are negative, be it the electrons of the atom's own, nucleus electrons combo, but it also applies to electrons of neighboring atoms. So because the positive charge on those neutrons not only attract the electrons that belong with them, but sometimes attract other electrons, this is a piece of the puzzle for understanding how the bonding is actually occurring. Because although we are capable of using Tinker Toys to simulate models, it's a little bit more complex than that when we talk about the reality of it. Now, depending upon when, if you have had college level biology, you may notice, or you may have heard, that bonding tends to come in three major types. We've got ionic, polar, sometimes referred to as polar covalent, and then there's the straight up covalent ones. Ionic ones are really seriously based upon that opposites attract idea. They call it the electrostatic attraction. We've got cations. Cations are positive. There are anions. Anions are negative. Sometimes those charges are a result of somebody stealing, one atom stealing electrons from a buddy. Now, in the terms of ionic bonding, a big portion of the time, that stealing occurs between the metals and the nonmetals. Let's pick on potassium. So this is one of the reasons why we needed to do valence electrons a bit in the previous chapter, because some of those ideas roll on into this chapter. Potassium is an alkali metal. It is in the first column under hydrogen. So that means it has one valence electron. Yes, there are more electrons, but there's only one in the outside layer. Now, bromine, a halogen, all the way over under fluorine on the right-hand side of the table, that one has 7 electrons. However, one of the comments that we did at the end of the previous chapter was to say that the closer an element is to fluorine, the more electronegative it is. Hence, things that are close to fluorine like to steal other people's electrons. In this case, the bromine is the thief. It is the one doing the stealing from the potassium. Now, here's a similar picture. I couldn't find an identical one for the potassium and the bromine, but this one gives you the idea. So look at the sodium. When it's intact, when the sodium has all of its electrons there on the left-hand edge of the picture. So we've got sodium, and sodium has 11 electrons as well as 11 protons. And we know, according to electronic configuration, that the first two of those 11 are in layer 1. And then the next 8 are in the S and the P parts of layer 2. But electron number 11 is in the 3s1 position. Well, that means it's exposed. It is way easier to swipe something when it's on the outside edge. Now, chlorine, being very close to fluorine on the periodic table, likes to steal. Fluorine and chlorine both have 7 valence electrons. If it steals one from the sodium, my chlorine now has 1 more electron than it used to have, which is one of the reasons it becomes a chloride, Cl-. But it also is the reason here indirectly that the sodium is now a sodium cation. It's missing an electron. It's still got the same old 11 protons that it started out life with, because 11 protons is what makes it sodium, but it's missing an electron. So I've got these 2 atoms that have done a bit of a swap here, and now they're both charged. This is where your whole electrostatic attraction thing comes from. My positive bit attracts to my negative bit. Ionic bonding is strong. Just like the rules we applied to nomenclature. You want equal numbers of positives and negatives. I tossed out a few more there as typical examples: lithium chloride, potassium bromide, calcium oxide. All of those are things that, if they are in their pure state, tend to be crystals. Now, here's where the Tinker Toy thing becomes a little more obvious. Even though we have this tendency to talk about these molecules as if they were, for instance, just 2 atoms, picking on lithium and chloride for a moment. Lithium and chloride as a single molecule with no other lithiums and no other chlorides is probably kind of unlikely. Because remember, molecules are small. Usually they occur in clusters. And in this case, the clusters have a regular and predictable pattern. So looking at my little color-coded picture here, we're going to assume that all the yellow ones are lithiums and all the green ones are chlorines. And note, it's not really just a single atom of lithium and a single atom of chloride. What you're really talking about that's closer to reality is a ratio. For every 1 lithium, there is a corresponding 1 chlorine. Now, it's mentioned briefly that this is a lattice structure. If you take 112, we will talk in a great more depth about the lattice structure. For this semester, we are just introducing the idea that this is really closer to how it is, as opposed to looking like one single little yellow dot and one single little green dot making a molecule. Now, ionic bonds tend to vary in their strength. They're not all the same. You can make measurements, and this kind of harks back a little bit to the stuff from the previous chapter of talking about that sometimes when we are doing measuring, we turn everything into a gas before we do the measuring. It has to do with trying to make sure there's consistency in the way the measurements are occurring. So if you converted a whole bunch of ions into their gaseous form, and then you allowed them to sort of coalesce or crystallize,
think about it,
then you get lattice energy. This is basically the way that it's measured.
Two can sing. Think about it. Asian.
So if ionic is all about the stealing,
so I would get rid of everybody.
Covalent is all about the sharing. Here's another term you might see thrown out to go along with the word covalent. You might see them referred to as non-polar covalent. We'll talk about the polarity part of it later, but non-polar covalent is pretty much equal sharing. You get absolutely perfectly equal sharing if you have two of the same atom. So I picked on chlorine. Chlorine is one of those that we know is diatomic, but then I found a decent looking picture that shows you oxygen and nitrogen too. If you have two of the same atom, in part because they have the same electronegativity, you get equal sharing. So if you look at the left-hand one, 2 atoms of chlorine.
Aren't you ready for college?
So for chlorine, which has 7 valence electrons, if you snuggle 2 of them up close to each other, you can see that little segment kind of looks like a Venn diagram right there in between the 2 black dots that are the nuclei of the chlorines. You see 1 blue little minus and 1 red little minus. And those are the ones that they are sharing happily, peacefully coexisting. For oxygen, earlier in the semester, we sort of blanketly said, oh, they're diatomic, they share. Now we get back to a little deeper into the why. Since oxygens have 6 valence electrons, if you put 2 of them beside each other, and you look at the little dots that are in the little Venn diagram share there, we've got red, blue, as a way to kind of make it a little easier to see the fact that we are sharing 4 electrons. It is possible to share 6, as in the nitrogen one. It is not possible to share 8 electrons between 2 atoms. You literally run out of physical 3-dimensional space. There is not a way, and there's actually deeper layers behind this. This is the intro to this part. But once you have 6 electrons, and look at your little diagram, little Venn diagram for your 2 green nuclei for your nitrogen there, we've got pairs of red, blue, 3 pairs there. And there are more electrons, but they're not between the nuclei. The remaining 2 of the left-hand nitrogen are kind of opposite, outer edge. And the remaining 2 blue ones of the right-hand nitrogen are kind of popped over there to the right-hand side. This is more truthful to how the bonding looks when it is actually complete. So we have one last variation on the theme then tonight, is what if it's really not stealing, and what if it's really not quite sharing? So here we get the middle situation. It's covalent, but it's polar covalent. So look at my little squiggles that are written underneath my H, and my O there. Each of those little squiggles that kind of looks like an unfinished number 8 is a lowercase Greek delta. Now, we've already seen uppercase Greek deltas because they look like triangles. We used them a couple chapters ago. Lowercase Greek deltas for chemistry and a fair bit in physics are used to represent the word partial. So the indication here is that the electrons are spending part of their time with the hydrogen and part of their time with the oxygen, but it's not a nice divorce, okay? There is a lopsidedness to this, in that your electrons are spending more time with the oxygen than with the hydrogen. So here's a somewhat better visual to go with that. Assuming that orbitals are fuzzy, we see here an oxygen and a hydrogen, but you can kind of see that most of the fuzz is kind of on the oxygen side, which then means the nucleus of the hydrogen, which is just a proton, is a little bit exposed. This is why it has kind of a positivity or a positiveness to that end of the bond. And if you look at the arrow that is drawn above the fuzzy picture here, you will see that the arrow has like a hash mark through the tail. This is an alternate way to indicate to you partials. Whereas, if I scroll back up here just a little bit, when I looked at this and it has the little deltas, the little squiggles, I have partial positive, partial negative. That's one way to indicate that there is an inequality to the way they're being shared. But you can also draw an arrow, and the idea is that the pointy end of the arrow is toward the negative end. And this is why you put the little slash, which kind of simulates a positive sign, through the tail end, back end of the arrow to help show which direction the negativeness is being distributed. So this is the beginning of chapter 7. We will spend some time going through homework on Tuesday and doing a little bit more in this chapter on Tuesday also. Nobody has classes on Wednesday. The college is technically open on Wednesday, the day before Thanksgiving, in that the administrative offices are going to be open for about a half a day. People I have on Monday, we have that one last lab. You do have a lab on the week of Thanksgiving, because that's literally the last time I am going to see you face to face this semester. All the rest of it's going to be Zoom. The lectures have always been Zoom for this semester. But there is one more lab after Thanksgiving, and I know I'm kind of rehashing this, but I don't see the same people necessarily every class period. There is one more lab after Thanksgiving, but it is not a face-to-face lab. It is a Zoom lab that will occur at 5:30 on December the 7th. So regular time for lab, just it's going to be a Zoom, and everybody is supposed to attend that session, both the A group and the B group, since we are doing it digitally. Questions? So beyond my little glitch with my camera and my internet, I think maybe this worked out okay. Otherwise, I will see some of you on Monday. And remember to turn in homework. Bye-bye.
Bye.